A train after traveling 150 kilometers meets with an accident and then proceeds with 3/5 of its former speed and arrives at its destination 8 hours late. Had the accident occurred 360 kilometers further, it would have reached the destination 4 hours late. What is the total distance traveled by the train? Okay, so this question is fairly easy, but it is a little lengthy. It has a lot of calculations. Okay, so let's solve this. Let's say there is no accident. Okay, there is no accident of the train, and then train travels d kilometers with s speed and takes t time. All right, but what the question is telling me, it is telling me that a train after traveling 150 kilometers meets with an accident. Okay, so out of this d kilometers, train travels for 150 kilometers, and after that it meets with an accident here. Okay, and then proceeds with 3/5 of its former speed and arrives at its destination. Okay, so after traveling 150 kilometers, train meets with an accident, and after that it travels the rest of the journey, which is total there is d kilometers. So what is the rest of the journey? It would be d minus 150 kilometers. It travels with, originally for 150 kilometers it traveled with s speed, and now it will take 3/5 of the former speed, which is s. Okay, so speed will be 3/5s. Now let's first calculate the time here. Okay, so time taken by train before the accident. So what will be that? Time taken by the train before the accident. We know that time is equals to distance upon speed. So here distance is 150 kilometers divided by speed, which is s. Okay, and time taken by the train after the accident, it would be again distance upon speed. Here distance is d minus 150 divided by speed, which is 3s by 5. So 3s divided by 5, and this 5 will go in the numerator and gets multiplied here. Okay, now the question is telling me that it arrives at its destination 8 hours late. So if there was no accident, it would have taken, the train would have taken t time, but now the total time taken by the train is 8. It reaches 8 hours late, so it takes t plus 8 hours. Okay, but what is this total time? Total time is time taken before the accident and time taken by the train after the accident. That means this plus this is the total time. So let's substitute it here. So we get 150 divided by s plus d minus 150 divided by 3s multiplied by 5, and this is equals to t plus 8. Let's call this equation 1. Okay, now had the accident occurred 360 kilometers further, it would have reached the destination 4 hours late. So now what happens is, out of this d kilometers, train travels for 150 plus 360 kilometers further. So it travels for 150 plus 360, which is equals to 510. So train travels for 510 kilometers and then meets with an accident, and then now it travels the rest of the journey, which is total is d minus 510. It travels d minus 510 with 3/5 of its former speed. So former speed was s, now it travels 3/5 of its former speed, which is 3/5 of s. Okay, now again let's calculate time taken by the train before the accident. It is again distance upon speed. So here distance is 510 divided by speed, which is s. Time taken by the train after the accident. Okay, here distance is d minus 510 divided by speed, which is 3s by 5. So 3s divided by 5, this 5 will go in the numerator and gets multiplied with this. Okay, and the question is telling me it would have reached the destination 4 hours late. So if there was no accident, it would have taken t time, but now it reaches 4 hours late. So that means total time taken here is t plus 4. Okay, but what is this total time? It is time taken by the train before the accident and time taken by the train after the accident. So that means this plus this. So let's substitute it here. We get 510 divided by s plus d minus 510 divided by 3s multiplied by 5, and this is equals to t plus 4. Let's call this equation 2. Okay, now in this equation 1, this t plus 8 can also be written as t plus 4, right? And this t plus 4 is the same as this t plus 4. So that means we can substitute this part for this t plus 4, right? So let's do that. Let's take the LCM here from equation 1. Let's take the LCM here. It would be, LCM would be 3s, and now 3 multiplied by 150 we get 0, 5, 450 plus 5 into d is 5d minus 5 zeros are 0 minus 750. Okay, and this is equals to t plus 4 plus 4. So let's put t plus 4 as this part, okay, because this is also t plus 4. So we get LCM of this is again 3s, okay, and 3 into 510 it would be 035, okay, plus 5 into d is 5d minus 510 into 5 is 5 zeros are 0, 5 ones are 5, 5 5s are 25, okay, and here is again plus 4 is there because we have divided into t plus 4 plus 4, so we have substituted for t plus 4, again plus 4 is remaining, so we have taken the LCM, so we get plus 4 into 3s, which is 12s. So this is what the calculation comes out to be. Now let's simplify. 3s gets cancelled, 5d gets cancelled, so what are we left with? We are left with 450 minus 750, which is minus 300, sorry, is equals to 1530 minus 2550. So it would be 1020, okay, in negative, okay, 1020 plus 12s. So now 12s is equals to minus 1020 goes on the left hand side and gets added with 300, so we get 720, right? So 6 2s are 6 1s are 6 2s are 0, 2 1s are 2 6s are 0. So we have got our answer. We have not got our answer, we just got the value of s, which is 60 kilometers per hour. So we know that speed of the train is 60 kilometers per hour. Now what is the question asking us? Question is asking us what is the total distance traveled by the train. Okay, so now let's substitute the value of s in equation 1. Okay, we can either put this value, put the value of s in equation 2, or we can put it in equation 1. I'm putting it in equation 1. So let's do that. Let's see what we get. I am erasing it because I don't have place to solve. I hope you can just rewind the videos and get to see what it is. All right, now let's substitute it here. We have 150 divided by s, which is 60, plus 5d minus 5 into this is 5 zeros are 0, 5 7, yes, divided by 3s, which is 3 into 60 is 180, is equals to t plus 8. So what is this t? T can also be written as distance upon speed. We know that t is equals to distance upon speed. So distance upon speed, speed is 60 and plus 8. So this is what it looks like after substituting the value of s in equation 1. Now let's solve this. Let's take LCM 180, 60 into 3, so 3 into 150 will be 3 zeros are 0, 450 plus 5d minus 750, this will be as it is, okay, is equals to LCM on the right hand side as well. So LCM will be 60, d plus 60 into 8 will be 48, 480. Okay, let's simplify. 61s are 63s are, so we get 450 minus 750, which will be minus 300, plus 5d is equals to this 3 goes on the right hand side and gets multiplied, so we get 3d plus 480 into 3 will be 1440. So we get this 5d, this 3d goes on the left hand side and gets multiplied, subtracted, so we get 5d minus 3d, which is 2d, and this will go, this 300 minus 300 will go on the right hand side and gets added, so we will get 300 plus this is 1740. So 2 1s are 2, 8s are 16, 2 7s are 0. So we got our answer D, which is equals to 870 kilometers. and this is our required answer. So this is how you solve it. We have got our answer D, which is equals to 870 kilometers. So here option C is the correct one.